Hi everybody, welcome back. This time we're going to graph discontinuous piecewise defined functions. So these graphs you should not be able to draw them without lifting your pencil off the paper. So let's look at our first example here. We have f of x. When x is less than or equal to 2, it is this transformation of the absolute value function, and when it's greater than 2, then it becomes this transformation of the quadratic function. So let's handle everything like we did before. So in our first step here, we wanted to graph this equation first. So this is x minus 1. So this is the absolute value function where all the x coordinates have been shifted by 1. So let our scale look like this 1 and 1, and our graph is going to look like this. So we'll have a point there, which I'm trying to draw in red, a point here, a point here, point here, a point here, a point here, and a point here, and we just keep drawing at these 45-degree angles. Just like this. So now we only want the part that is greater than or equal to 2. And notice that so since 2 is right here, we want to get rid of all this part here. And so notice that just leaves me a filled in dot. And why is it a filled in dot? Well, that's because we have equal sign here. So we need to put in a filled in dot. Now, we need to graph the other function, which I'll do in blue this time so it doesn't look Christmassy like it did last time. So we have negative x squared plus 4. So that graph is going to look like this. Let's see, 5, 6, 7, 8, 9. 9. So this is what the graph of that function will look like. It's not as curved as I would like. There's that. Let's try one more time. Like that. Good enough. So now again, we now only want to consider this function when it's greater than 2. So again, here is 2. Notice that we are not got an equal sign, so we're going to have an open dot here, and all this part that's in blue we erase. And I'll fill in the missing pieces here. So let's see, there, and there we go. So this function does this. Then if I trace through it, it'll start up here, it'll come down here and kind of do a little check mark thing, and then it will, once it gets here, it jumps down and follows the path here. So this is a discontinuous function here because there's this jump right here between the left piece and the right piece. And that's how you graph. So the function is just then, let me get to a more standard eraser here. So our graph actually is going to just look like this. Let's see, it's not, try to get there. So it's this red and blue part combined. Alright, so let's look at one more graph here. So this is our function, and I forgot to change this. Let me just do that real quick here with the keyboard. That was a typo. This is the exact same one from last time, but notice that this time what I changed was I took this less than or equal to and I turned it into an equal sign. So, or I took away the equal sign. Right there. So what effect does that have on the graph? Well, it's going to be almost identical to the graph we had last time, so I'm not going to redraw it. I am just going to copy it from last time. So here's our graph from last time. Let's see if we can copy it. We should. There we go. Let's copy it and bring it over. And what is the difference here this time? Let's get this up here by what we're trying to study. There we go. Good enough. And what's the difference here? Well, last time, remember that when we drew in this green piece here, it actually filled in the dot here. And that was because we had an equality sign right. Let me get the right pen here. We had a equality sign right there. So now we have no equality sign, so let's see how that changes things. Here that we have filled in, and we actually didn't fill it in, so there's just a circle right here. So this graph, so that's the difference here between having an equality here and having non-equality here, is that this, it depends whether this point gets filled in or not, and that depends, and that completely determines whether this is a continuous function or not. If it's continuous, this dot gets filled in, and if it's not continuous, which in this case it's not, this dot did not get filled in. So I just wanted to point that out as kind of a special case. So we'll move on to our next video about holes in graphs. We'll see you.